Hi all, this is Mrs. Smith. I'm just going to quickly take you through what GCSE Computer Science is. We here at Lutterworth we have two offerings within the Computer Science department. As well as the Computer Science, we also have the Level 2 BTEC DIT, which is Digital Information Technology. This course though is GCSE Computer Science and the exam board is OCR. This course combines your practical skills of computer programming with your theoretical understanding of concepts. By that I mean, how does a CPU work? How does networking work? What are the ethics of using computer science and the legislation that we must adhere to? So it covers a range of topics. Skills that you're going to learn them. So a lot of skills in programming. Of course, you must be able to program in Python, and we give you the skills in order to be able to do that. You've already started that at Key Stage 3, so it's about developing those skills to be able to solve problems. You're going to develop your understanding and ability of computational thinking, so how we go about devising programs to solve problems that are set. And we also look at pseudocode and being able to write in it. Now, this is for when you are writing your written exam. You might be asked to write an algorithm out, and you'd need to know pseudocode in order to be able to do that. Key thing, though, is you're going to really learn how to write programs to solve problems. So how will you be assessed? Well, you've got two written exams, both worth 50% of the final grade. You will also still have to show evidence of programming, and completing a project is part of that evidence. So although you will not get a mark for the programming, we have to say that you have done so much programming over the course of the GCSE to ensure that you have got the skills to sit the exam. So two exams then. The first one is to do with computer systems, and this will cover things like systems architecture. By that we mean, how does the CPU work? Fetch, decode, execute. They're words that you might remember from Key Stage 3. If not, we go right back to the beginning. Memory and storage, so RAM, ROM, solid state hard disks, CD-ROMs, you name it, we talk about it. As well as that, there's also in there binary and hexadecimal, so zeros and ones, and how the computer can understand how everything works. We look at computer networks, connections and protocols, and also along with that, network security, so LANs, WANs, how the internet works, how we protect against hackers. We've also got system software, so this is your operating systems, utilities. And then finally, ethical, legal, cultural and environmental impacts of digital technology. Sounds a lot, but basically, what ethics is there when we're using computers? We look at Computer Misuse Act, the effect that, the consequences for people hacking, developing malware, those sort of things. Then the other exam is computational thinking, algorithms and programming. So this is more the programming paper. So we look at algorithms, different sorting and searching techniques. We look at the fundamentals of programming, so the different data types, how we declare variables. We look at producing robust programs, so how we test them, make sure they work. Boolean logic, so logic gates, so a bit of electronics comes into this. And then programming languages and integrate development environments. So we look at how programming languages are used, and then to actually develop different problems. Examples of work then, there is written work. So here's an example of when we were looking at encryption and actually developing the Caesar cipher, and so you can have a go at making your own cipher codes. And then we could look at things like cloud storage. So the advantages, disadvantages, what it means, and we develop these little workbooks as we go through. Then on the other side of the course, you've got flowcharting, being able to develop a flowchart to symbolise what is going on in your program. Then you've got your Python programming, which you need to be able to annotate and be able to do to solve a particular problem. So what can you do with this subject? Well, it goes well with maths, physics, further maths, D&T, further study A-level in computer science also. And further down the line, students have gone on to study games design, software engineering, engineering in general. So there's lots of opportunities out there if it's something you are interested in. If you do have any questions then regarding this course, then either contact your computing teacher or contact me, Mrs. Smith. I've left the email addresses there. If you're not sure, please ask. It's best to make sure you get onto the right course. Okay, thank you, bye.